Good afternoon and welcome to Creating Your Virtual Data Center, VPC Fundamentals and Connectivity Options. Make sure my pointer's working here. My name is Brett Holman. I'm a manager of solutions architecture at Amazon Web Services. You should be here to learn more about VPC and building out your virtual data center on Amazon. Today we're going to define all of the components of VPC, how they fit together, and dive into 15 best practices and things you should consider when building out a VPC on Amazon Web Services. So just an FYI, this talk does go into networking a bit. It's not super deep, but being a little network savvy is important. So just wanted to give you that heads up before we get started. All right, so here's the agenda. We're going to talk first about what is Amazon Virtual Private Cloud. Then we're going to dive into some of the high-level use cases you might use VPC for. Then we're going to go through the basics, all the different components, how they fit together in relevant architectures. And then we're going to dive into the 15 best practices and design considerations you might want to use for VPC. So I'll also tip you off, the next talk in here is also on virtual private cloud. It's kind of a good add-on to this one, so it'll go into some of the more advanced topics after this one. So what is Amazon Virtual Private Cloud? You know, really, it's a private space you can build apps and services on AWS. Or maybe it's a set of software-defined networking tools that allow you to build out your own network footprint in the cloud. But you know, most simply put, it's really a virtual data center on AWS. And not only is it a virtual data center on AWS, it's also a virtual data center that spans multiple physical data centers on Amazon Web Services. So really, underneath the covers, it's a highly available data center on top of Amazon Web Services in the cloud. So let's talk about what some common use cases are for VPC. And first off, let's talk about a public web application. So, you know, any public web app can be run on your VPC. And all your servers can be made publicly available. So here's an example. You've got a web stack running inside of your VPC, as you can see there. And you've got something called an internet gateway, which actually opens that VPC up to the internet. You've got your user who's coming in through that internet gateway, and they also might be getting static assets off of our CDN and out of S3, which might be the origin for that CDN. So this would be a good example of a public web app inside of Amazon Web Services at a high level. And we're going to get to more detail as we go on. Totally private web applications with no public access to any resources externally from the internet is also another really good common use case for VPC. So here you've got a user sitting in a corporate data center, connecting over VPN to their Amazon VPC and hitting their web server instances, maybe running a private internal company web app. So this is another great use case for VPC. A virtual data center on Amazon Web Services, or adding another data center to your already big data center footprint would be another use case. You can build that virtual data center on AWS, and this shows kind of a hybrid scenario here. As you can see, you can replicate directory services or run directory services in the cloud, extend your data center footprint, store keys for encryption both on-prem and in your cloud HSM inside of your VPC. You can also push backups to AWS's expandable storage options in the cloud. And you can also run on-premise, hybrid, and cloud-only apps. So this would be a good high-level example of that. The last example I have before we move on to the next section is disaster recovery. So we have 4 different disaster recovery scenarios. If you've ever seen our disaster recovery white paper, it's a good white paper to take a look at. It talks about 4 different scenarios: backup and restore, pilot light warm standby, and multi-site active-active. So this is an example of the pilot light scenario. Here, basically what we're doing is we're running a web stack over in the data center. We've gone and we've cloned that and created images of web servers and app servers that are just the same, running over on EC2 and Amazon Web Services. We've left them in a stopped state. And what we're doing is we're replicating our database across the VPN over to a database that's running on EC2 in Amazon Web Services. So now we've got our data replicated to Amazon Web Services. In the case of an outage, what we're going to do is we're going to rehydrate these server tiers, start these servers and maybe scale them out horizontally on both the web and the app tier. We're going to maybe stop and restart the database tier, so we now change the size of the database. We may have been on a very small database size, now we're going to grow it to a very large database size to handle our prod load, and then we're going to repoint our DNS. For your RTO and RPO, this might be a really good solution. Maybe you want more of a warm or hot standby type solution as well. So anyway, take a look at the white paper. So yeah, hopefully this doesn't look like your data center. And hopefully it never will be again if you use VPC. So everything is taggable and queryable via API. You'll never have to inventory something like this, or even a neat data center for that matter. It's still a large job to inventory your data center. So everything inside of AWS is taggable inside of VPC. So you can actually tag it with things that are specific to your project or your business unit or whatever it might be. And then you can query those things. So you can actually discover what your resources are very easily. And we offered some, announced some new services today that actually might even make that easier. So moving on, here are all the components of VPC. We're going to dive into each one of these, so let's just dive right in. So VPC, this is really your virtual data center and Amazon Web Services. You start by defining a CIDR block of IPs that define your network. Typically, it's going to be RFC 1918 space. So a VPC is a virtual data center that can span multiple AZs, like I mentioned before. So really, this is an HA data center in a sense. And when you create a new account today, there's something called a default VPC out there. And you automatically get this default VPC. We create that for you as part of your account creation. So what this really is when you're launching an EC2 instance and you don't target it for a specific VPC or a specific subnet, an untargeted launch in a sense, it's going to go into this default VPC. And this default VPC makes available to you a lot of the things that were available in the old EC2 Classic world. But you get to take advantage of a lot of the new features that are in VPC. There's a lot of advanced networking features that aren't available in the old EC2 Classic world. So. A subnet is a range of IPs in your VPC. And you can divide up your overall VPC into multiple subnets for different uses and purposes. We're going to talk more about what those different uses and purposes are. A subnet lives inside of an availability zone. You can provide security at the subnet level. With ACLs, we're going to talk about ACLs more and what ACLs should be used for versus security groups. Also, each subnet can be routed differently as well. So you can pick how you route a subnet, which gateways you specify as allowing egress from, and so on. And then going back to default VPC, each default VPC we create has a default subnet in each availability zone in your account with a route to the internet gateway, which makes that particular subnet for that default VPC publicly available. If you launch instances into it, you give them public IPs, they're now publicly available instances. All right, internet gateway enables your instances to connect to the internet through the Amazon Network Edge. So this allows you to hit public API endpoints or things such as S3, public internet, whatever it might be, DynamoDB, SQS. So you need an internet gateway to actually make that possible. And inside of the default VPC, there's always that internet gateway. The subnet that we define as the default subnet, again, has a default route to the internet gateway, so you can always go out and hit things from that default VPC if you're using that as opposed to building out your own VPC. The virtual private gateway is a logical construct, and this represents the VPN endpoint in the AWS VPC to terminate your VPN connections. So it's also the endpoint for direct connect connections as well. We're going to talk more about direct connect and what you might do with direct connect later in the talk. One note, without an internet gateway or a virtual private gateway, can you get into your VPC? What do you think? Probably not. No access. Can't come in privately, can't come in publicly. So here's an example of that. Your customer gateway is your endpoint on your end that actually terminates the VPN connections or the direct connect on your end. And typically going to be a router or firewall. And you can see the VPN connection extends from the customer gateway to the VPN gateway. By default, every subnet can talk to every other subnet inside of a VPC. So this is enabled by a virtual router that sits in a star topology between all your subnets. To get to this router, the VPC DHCP service hands out a .1 default gateway in every /24 subnet so that you can actually talk between all the VPCs. That's how you get out. That's the default gateway, the .1 address in each VPC, or in each subnet, excuse me. And this would be an example of that star topology. So all these instances can talk between all these different subnets, barring any security groups or ACLs that prevent that. A route table is a set of rules or routes that are used to determine where to send network traffic based upon IP prefix. So each subnet in a VPC must be associated with at least one route table. The route table contains rules for what gateways you can go out to, and you can apply this route table to many subnets as well. So here's an example of a route table with a local route. Every route table has a local route, which says the subnets in the VPC can talk to each other. And then in this one, we've also got a default route, the 0.0.0.0/0 route. that says, hey, any route that's not further specified above, send all that traffic out to the internet, through the internet gateway. So I can hit the internet through that or the API endpoints. And here's an example. Both my subnets have routes out to the internet gateway and can hit the AWS public API endpoints or the public internet. VPN connection, we've talked about that quite a bit already. Here's an example of a VPN connection between the VPN gateway and the customer gateway. An elastic IP is a static IP address that's associated to your account. When you release the address from an instance, it still sits in your account. You can assign it to another instance in the same region. That's pretty handy if you want to do high availability between availability zones and you have got an instance that's got an IP address running and you want to go and move it to another instance running in a different data center. You can do that without updating DNS. You're good to go. An elastic network interface is an interface that allows you to do that. So an interface has to live inside of a subnet. So an ENI is a virtual interface that you can attach to an instance in a VPC. There's the Ethernet 0 interface, which is the default interface, but you can always attach an Ethernet 1 interface or further interfaces, and those are actually movable between instances inside of a subnet. So there's a bunch of good use cases we're going to talk about later in the talk around moving ENIs around. But essentially, an ENI consists of your MAC address, your private IP, and if you have a public IP, your public IP as well. All right. Network ACLs, or network access control lists. Essentially, these are an optional layer of security that acts as a firewall around your subnets. They really control the ingress and egress policies for a particular subnet, and it's a numbered list of rules that we evaluate in order, starting with the lowest numbered rule to determine how traffic ingresses and egresses a particular network or subnet. So next we're going to talk about security groups. This is at the subnet level or the network level. And these are stateless rules. So when you apply these rules, you've got to apply them both to inbound and outbound, as opposed to security groups, which we'll talk about next. So a security group acts as a firewall around your EC2 instances, and it controls inbound and outbound traffic as well. When you launch an instance in a VPC, you can assign up to 5 security groups. And security groups act at the instance level, not the subnet level. They're stateful, meaning if I open up port 80 and 443, I'm going to allow a stateful response from my web server, even if those ports aren't available. So security groups are stateful. You always have at least one around an instance, and you got a max of 5. So let's talk about some of the security controls that exist inside of a VPC. So first off, you got a CIDR block that you define. In this case, it's going to be the 10.1/16. Then we're going to subnet that out and split that into 2 subnets, the 10.1.0 or the 10.1.1/24 and the 10.1.10/24, as you can see in the example. Then we're going to go and apply ACLs if we choose, which are the ingress and egress policies that wrap around that network. Then we're going to go assign route tables. The subnet on the left, the 10.1.1, has an egress to the internet gateway. The subnet on the right has an egress to the VPN gateway. And then lastly, we're going to go launch instances. And the instances live in particular subnets. And they're going to be wrapped by security groups, which, again, are stateful. All right, so let's look at an overview of VPC. So here we got your customer network on the right, internet on the left, and in the center we got our VPC. And we've got what we're calling a public subnet and routing for a public subnet on the left, a private subnet on the right. And what makes the left a public subnet is going to be both the routes to the internet gateway and the public IPs that are assigned to the instances. What makes the right a private subnet is the fact that we've got a route back to our corporate data center. All the servers only have private IPs. And lastly, we did add something called a NAT route, which is a default route on the bottom of that route table on the right. And that basically states that all those servers actually can get internet access through a NAT instance that's running in the public subnet that does port address translation and allows my servers to go out and make a stateful request to the internet and get a stateful response, almost like your laptop behind a firewall in your own corporate LAN environment or something like that. So this would be a good VPC or a good overview of a little hybrid architecture inside of VPC. Okay, so now let's change gears and actually go into some of the best practices and things you should consider when building out your virtual private cloud on Amazon Web Services. So first off, think about the controls and processes you put around config, changes to routers, switches, and any network components you might have in your data centers. And that same approach should exist here. You want to use identity and access management to create a VPC admin group and only permission this group to any of the high blast radius API calls, such as these things that are, all the deletes and so on, all the updates and deletes. And make the people that own this, a small group, and make that a small and responsible group. And then add these 7 delete calls, or these 7 delete calls now in here actually support EC2 resource-based permissions. We're going to talk a bunch more about that coming up, but needless to say, what that means is I can say, hey, I tagged this particular VPC as my dev VPC, and maybe I'll only allow a particular user to delete items in something that's tagged as my dev VPC. So I've got the ability to do things at the resource level, and that's what resource-based permissions are. We're going to talk more about that. Okay, so plan your IP space before creating it. This is really important. First, consider the IP space you use on-prem in your own data centers, your own corporate LAN environments, and so on. You probably don't want to collide on that IP space. If you want to join your data center on Amazon with your own physical data centers, you probably don't want IP space that overlaps. Otherwise, that's going to cause some confusion. You're going to have to NAT things and so on. So make sure you plan your IP space accordingly. Next, think about what future expansion will do to your IP space. Let's say you're going to build an app across 2 availability zones, but maybe in the future that app's going to be a really scalable app, and you might want it to span 3 availability zones. Make sure that your IP space you plan in your VPC can grow into that, because you can't change your CIDR block once you pick it in a VPC. So always have an even distribution of IP space across availability zones as well. Remember, subnets live across AZs. If I'm going to have 10 subnets in one AZ, I should probably have 10 subnets in the other. If I'm going to have a third, I probably need to have another 10 subnets to scale across. Subnet design is also very important. We're going to talk about that next. But some customers have very large dynamic application workloads with thousands of servers, thousands and thousands of servers in a large subnet, right? Others, smaller subnets, maybe /24s that better fit their, application tiers, something like that might be appropriate. So think about those types of things when you pick your IP space, how big it needs to be, how you want to subnet. We're going to talk more about subnetting on the next slide here. So digging a little deeper into subnet planning, first, subnets are single AZ. So plan accordingly, and then plan accordingly based upon how many subnets you plan on using later as well. Integration with on-prem networks is important as well. And you may have different rules for which app tiers you want to be able to talk back to your on-prem network. So that might not be another reason you need a subnet, right? You do routing-based rules at the subnet level. So if I'm going to do routing-based rules at the subnet level, I might want to subnet things that can talk to my on-prem network versus things that can't. Or maybe certain areas of my on-prem can talk to certain subnets, but other areas can talk to other subnets. It's however you lay it out, you need to think about those types of things in advance. You also might be doing subnet level access control with ACLs, and if you're going to apply that, maybe some workloads are going to respond well to those ACLs and others won't. So that might be another reason to subnet out. And lastly, if you want to peer your VPCs together, you may want to have certain subnets that can talk across the peering link and others that can't. And if you couple all your servers together in a single subnet, how are you going to differentiate them? By single IP addresses? That's not going to work. That's not very scalable. So maybe if I want multiple VPCs talking to each other across VPC peering, which we're going to talk about later, I might want to subnet for that reason as well. Network ACLs versus security groups. So let's talk about network security and talk about these two concepts together. So you're probably familiar with security groups. I think if you guys have used EC2, you've used security groups. Not everybody's used ACLs. How do these two differ? Well, primarily, NACLs are an order-based set of rules, processed in order. You want to put your most commonly matched rules at the top of your NACL list. They're stateless, so you have to specify both ingress and egress rules. Security groups are stateful. So again, if we've got port 80 and port 443 that are open inbound, I'm going to allow a stateful response on the outbound from the ephemeral ports for my web server. I don't need to specify those. So what do you use ACLs for? Well, there's a variety of use cases you could use them for. I would think of them, though, as enforcing a baseline security policy, such as the example here. No FTP, NetBIOS, or SMTP shall egress this subnet. Catch-all for holes in instance security groups. This is something, where you can have a segregation of security concerns between the app teams who are building their applications with certain ports open and the network security organization who might say things like, I don't ever want to allow these things to happen out of this network. Or this is a database subnet and I only want traffic in of this type from these particular IP ranges. You know, you can be very granular, but you only get a max of 20 rules. This isn't an infinite set of rules, so you know, if you're going to use them wisely. You know, a lot of people are used to only using security groups, and that's okay. But if you want to separate those concerns and you want to put some baseline security in around certain networks, this is the way to do that. All right, so every subnet must have an associated route table, and you can't specify a route table when you create a subnet. So every subnet you create starts out assigned to the main route table, and it's only after creation that you can edit that route table and change it to a different routing table. So you go into the subnet, you say, I want to change the routing tables. Well, for that reason, leave the main routing table as it is with only the default local route, and you won't have to worry about a new subnet being given a route to something it shouldn't have a route to, right? You know, you create a new subnet, and all of a sudden it's got a route out to the public internet, and maybe routes back to my corporate data center as well. And you know, I didn't really think about that. Wow. Or I didn't edit the route table. I forgot to do that. If you leave it as the main route, you know, leave the main route table alone, that issue won't happen. So, all right. So enhanced networking in VPC. So only the VPC stack supports enhanced networking capabilities. EC2 supports something called SRIOV, or single root IO virtualization, and this basically enables higher packet throughput, higher performance, lower latency, lower jitter, and so on your instances. And this is supported across a lot of the new instance types, the C3, the I2, the R3, and other instance types, if they're launched from the HVM AMI. And so if you use Amazon Linux, the Amazon Linux AMI, with these instance types on the HVM AMI, the driver and configuration is already done. It's already set up to do that. This is supported, however, on other Linux flavors as well, and even on Windows. So. We already discussed ENIs a little bit, but take advantage of these in your VPC. There's a couple really cool use cases for these. First, the ability to create something called a dual-homed instance. This allows you to have an instance in two different subnets. So let's say I might put an instance in two subnets, and one of the subnets might have access to the public internet, and maybe the other one sits back on my management network. So I could go and have separate rules, separate ACLs, two different interfaces, and dual home that instance. I can also have multiple interfaces on a particular instance, so with multiple IPs. Let's say I'm running an instance and I need a ton of IP addresses, a ton of public IPs on that. Well, one interface can only handle a certain number of IPs, but I can add multiple interfaces and actually add multiple IPs to each interface, and then I can grow the number of IPs I can have across that instance overall. Lastly, we're going to talk about something called poor man's high availability, or that's my name for it. Maybe not the best name, but we'll talk about that on the next slide here. So what is the floating interface pattern, or poor man's HA? Let's say you've got a legacy application, or you're running a virtual appliance in your VPC, or you've got something that is running and it can only vertically scale. It can't horizontally scale out. You know, it's not this cloudified application. It only can run on a single server for whatever reason it is, right? Well, you know, I've got the ability to spin this up and attach an Ethernet 1 interface to this instance as an ENI, and that Ethernet 1 ENI can be moved with private address, public IP address, and MAC, all to another instance running in the same subnet. So let's say I've got an outage scenario where that instance goes down. I could have a warm, hot standby sitting in that same subnet, or even a cold standby that I might boot. It might be a stopped instance that's ready to go when I boot it, and then attach that interface. I don't have to update any DNS. I'm up and running. So, you know, I mean, it's poor man's high availability, right? You know, you could even use CloudWatch alarms to signal that that instance went down, have a script that knows how to assign that ENI to the next instance upon receiving that alarm. So you could have a little admin server that's watching that and actually goes and makes that assignment. So you could do this pretty rapidly and have a small downtime for something that's used to running on a single server. So, you know, it's not like a horizontally scaled application where, you know, you lose an instance, auto-scaling kills it, ELB stops sending traffic to it. I mean, you don't have that option on a single server, but this is a pretty good pattern for HA, as is the EIP if you want to do it across availability zone. All right, so tag everything, you know, really good advice. You know, use tags that answer questions about your world or your organization. Decide on a schema early and stick to it, you know, and build tags around that. I'm going to give you an example on the next slide. And then IAM control, who can modify and create tags. so that people can't edit tags, so they've got access, so they get access to things they shouldn't. Remember, we have EC2 resource-based permissions that allow us to actually limit who can access resources based on tags. So remember also that everything's queryable via tags. So I might want to query based on business unit or project ID or whatever it might be. So everything's queryable via tags. So that's important as well. Talked about resource-based permissions. We'll talk about that more. Also, you can parse billing items. You can parse billing on tags. So you can actually pivot your data. You can actually download, have all your billing data pushed to S3 with the tags on it, and then you can actually pivot that data. And there are also vendor tools out there or third-party tools out there that allow you to do this, that allow you to go sum things up based on tag ID. So you can go do chargeback and things like that. So here'd be an example of tagging. This is just some basic tags I put on my VPC, but these can go on subnets and all sorts of resources. But I named my VPC. Said the business unit's core engineering, my environment's production, my project ID is 1, 2, 3, 4, 5, 6. If I wanted to go and find out at the end of the month all the things that were 1, 2, 3, 4, 5, 6, I could go pull all the EC2 instances, all the EBS charges and all that stuff and sum it up, and again do chargeback. And further, I can actually do some EC2 resource-based permissions on that as well, which leads me to my next set of slides. Use IAM to define and enforce a VPC's operational state. So you can build security into IAM users, roles, and groups at the resource level. This list is always growing of services that accommodate that and resources that in the EC2 pool that accommodate that. It's pretty close to being pervasive at this point. But an example, EC2 Run Instance API call supports resource level permissions around a wide variety of controls. And you can specify exactly what can be launched where using these permissions. So some examples would be, I've got a dev IAM group, and you can only launch it. That can only launch instances into the tagged environment equal dev VPC, or something similar for prod. Maybe I can only launch things with an AMI labeled prod or tagged as prod in my prod VPC. So I can build rule sets like that or policies around that, and then attach those to users, groups, or roles inside of IAM. And here would be an example of such a policy here. This policy locks things down to users only being able to launch things in a particular subnet with a particular security group. So maybe my security team helped me define my security policies, my security groups. I lock down controls over who can access those and edit those. And then I give my users access to only launch in a particular subnet in prod with a particular security group. And I may even have a particular AMI. Or I may even have an AMI that's tagged as prod AMI, like we talked about in the last slide. So there's a good article. It's called Demystifying EC2 Resource Level Permissions. There's a link to it on here. These slides will be made available after reInvent, so you can find that link. And if you just Google that you'll find the article. Okay, so how do I access the internet from my VPC, or how do I access public endpoints like S3 from my VPC? So there's a few things. First, should I backhaul through my own corporate network, out my own corporate firewall to get to things like S3 or to the public internet? Maybe. We'll talk a little more about that. We'll also talk about public route with a public IP using NAT, and then making NAT highly available, and scaling out your NAT is something Yanal in the back of the room is going to talk about in the session after this. So I'd recommend you stick around. That'll be a very good session as well. So first off, do you want to do this? So this would be backhauling through your own firewall at your own VP or your own corporate data center. And I just wanted to call out the use case. So let's say your corporate data center is in Chicago, and your VPC is in US West Oregon, and you've got 50 milliseconds across your VPN on average, and you want to go put and get things out of S3 quite often. Your apps need to grab files out of S3. You got to go all the way back through your own corporate firewall, 50 milliseconds, then probably 50 or 60 milliseconds across the internet back to S3, then 50 or 60 milliseconds back, and then 50 milliseconds back to your instances. You're talking about 220 milliseconds. Let's say you're doing a lot of traffic back and forth to S3. Is that a good pattern? Probably not. I would say you might be hogging your internet connection as well. I mean, why not use AWS's internet connection inside of an AZ? It's free. Better pattern there. So a lot of people at first don't want to necessarily open up their VPC to the public internet. They may have security concerns. It may not be vetted yet, with their security teams. So this might be where you start, but this is probably not your end game. That would be my thought. So I really like this pattern. I actually tell all my customers this is a great place to start, especially if you're doing a lot of traffic back and forth to S3, which is a very common use case. I mean, applications are putting objects in S3, getting things out of S3, processing things in S3 and putting them back, especially if you're doing big data inside of your VPC. I mean, you're going to be going back and forth a lot. And you might say, well, I'm going to define a public route from my subnet out to the public internet. I'm going to give all my instances public IPs. Wow, I don't want to do that. That's crazy. Well, it's not really that crazy. Really, if you think about this, with security groups, I can say I don't want any inbound access to my instances in there. I can lock down my security groups so nobody can edit those. Then when I launch instances, I can force people to use that security group. I assign a public IP, and now nothing can reach my instance because there's no inbound access allowed through my firewall, but I'm allowing outbound access to S3 with a stateful response. So, quite safe actually, right? And this is a common thing that people are concerned with, but this is actually a really good pattern. So anyway, here's an example of that. The other one that people use quite often is NAT, network address translation. So in this case, I've got instances in private subnets, and I don't want to expose these to an internet connection. How do I accomplish this? So you find the AMI to deploy a NAT instance. You launch it in a subnet that has access with a route to the internet gateway. You assign an EIP, an elastic IP address, or a public IP address. Then you disable source destination checking. What does that mean? What that means is I'm disabling the check that requires that EC2 instance to check that it's the destination of a packet. In the case of a NAT, I want to send my packets out to the internet. The NAT is not the endpoint. So I disable that checking so the NAT doesn't throw an error. Hey, I'm not the destination of that packet. Something's wrong here. So I've got the ability to disable that on the NAT instance. And then after that, I create a default route for my private subnet to the NAT instance. And now all my instances can do a stateful request through the NAT instance out to the internet and get a stateful response, but none of those instances are publicly addressable. And further, I can go take my NAT and say I don't want any inbound traffic allowed from the internet to my NAT. So again, doing what I did in the last talk, or in the last slide. And then lastly, let's say I'm only using the NAT for updating patches and things like that. Maybe I just turn the NAT off in between patching, I could do that as well. And then I've got nothing coming in through the public internet into my VPC while I'm not patching. And then if I want to patch, I go start the NAT up, let it boot. I can go hit the download patches and so on. It's a good pattern. So Yanal is going to talk much more about how to make this highly available in the next talk, and he's also going to talk more about how you scale out a NAT. So let's say you're running something in your private tier, you don't want it to have access to the public internet, and you want to be able to scale out that NAT tier so it can actually do massive throughput to things like S3. That's going to be something in the next talk. So how do I connect my VPC to my own data centers? One of the keys to running a hybrid app and hybrid architecture is having private connectivity to your VPC. So how do you do this? VPN's typically the way to start. You're going to start with redundant IPsec tunnels. This supports BGP and static routing, and you can actually set up redundant customer gateways. So essentially that's going to allow you to have a redundant gateway on your end of the connection. So let's take a look at that. So this would be a single VPN connection here, and notice that it actually has access to both availability zones. So essentially, you're not actually tying up a VPN connection to one AZ, you're actually tying it into the region, and that region now has the ability to talk to all the different availability zones in the region. So over that VPN, your data center can talk to all the AZs. And you can also have multiple VPN connections. So this is a great pattern as well. Each of your data centers has access to the VPC as well, and now you're not bringing everything across your own private network and through a single VPN connection. No bottlenecks, less choke points, single point of failure issues, and all that. So this would be another use case. So what does it really look like? This would be an example of redundant tunnels for your VPN connection. So we have 2 VPN endpoints in each region, and you will terminate tunnels to each one of those VPN endpoints. And we always recommend you use a BGP-capable device, so when possible. So you can use static, but BGP-capable when possible. And that offers you the ability to detect failure and fail over from tunnel 1 to tunnel 2 quite easily. Devices that don't support BGP, some of them support health checking and some things like that, but that's really going to come down to the device manufacturer and so on. So this would be an example of redundant tunnels so that if tunnel 1 goes down, you fail over to tunnel 2 and your application is still able to talk back and forth. You also have the ability to run redundant customer gateways. You can run these redundant gateways in your own network environment with dual customer gateways using a protocol like VRRP or HSRP, which provides a default or a tolerant default gateway on your end. And then, of course, you'd use BGP to choose tunnels back and forth or provide routes to AWS as to the tunnel preferences and so on from each router on our end. So this would be an example of redundant customer gateways. So how many VPCs do you need? This topic's going to be covered in depth in the next talk, so I'm just going to touch on a few points here. Maybe you've got distinct application stacks with little or no dependencies, and you want to put them in separate VPCs. EC2 resource-based permissions doesn't segregate everything, so maybe there are some reasons why you want to put things in different VPCs and potentially different accounts. Potentially you want to have your public apps running in a different VPC or different account than another set of private apps. Limit blast radius, those sorts of things. So many different reasons why you might want to actually have multiple VPCs and multiple accounts, and Yunal is going to touch on different use cases for that in the next talk. Use peering to connect your VPCs together. So if I've got multiple VPCs, how do these VPCs talk to each other? Not too long ago, you would have done that with either SSL certs between the VPCs through the public internet gateway or via VPN connections between your VPCs. But you don't have to do that anymore. Now you can actually use VPC peering, and it allows you to peer VPCs within the same region. They don't have to be in the same account. You can have different accounts, and one thing, the IP spaces cannot overlap. They've got to be different IP spaces. So you set up the peering connection between VPCs. One VPC does a request, the other one accepts it. Then you need to open up routes so the two can talk to each other over the peering connection. And lastly, you want to actually make sure your security groups don't block that traffic on either end. And now you can talk over that peering link. And there's no bottlenecks, no single points of failure. So this is a great architecture for talking between VPC. And you can talk at high bandwidth between these. So at some point, you might look at productionizing your apps inside of AWS, or moving large amounts of data back and forth, and you need to move to that next level. So here's where Direct Connect comes in. You actually can use a private network connection that bypasses the public internet, some kind of a private circuit that actually links your data center up with AWS. So many reasons why customers choose to use Direct Connect. Could be network latency, jitter, better performance, more consistent performance, or potentially cost, and we'll talk more about costs coming up. There are also two different scenarios. There's the Direct Connect from colo to Direct Connect POP site. So let's say you're coloed in a Direct Connect POP. How does that work? Well, what happens, essentially you go and order a port in our Direct Connect console, 1 gig or 10 gig. You get LOA CFA back from us in 72 hours, within 72 hours. What that is, that's a letter of authorization for carrier facility assignment. What that means is we're giving you the authority to cross-connect to us on specific ports we provision for you in our cage. So you take that, you order the cross-connect from your provider, and you give them that LOA CFA, which authorizes them to make a cross-connect on your behalf to AWS in a particular cage where we're located in that POP site. That would be scenario one. Scenario two, you're in a remote site. And in this case, again, you order the port in the portal for the region you want, 1 gig or 10 gig. Then you go order a circuit with with a telecom provider, preferably one of our partners, and you order the circuit and you give them that LOA CFA again. That authorizes them to order the cross-connect on your behalf. If you are not coloed at the Direct Connect POP sites, you cannot order the cross-connect on your own. You actually have to do it through the provider. The provider needs to order that for you. So it's a common misconception or mistake. Don't make that mistake. Provide the LOA CFA to your provider, and they will extend the circuit all the way to AWS. Lastly, you might wonder, how would cost be lower with Direct Connect? I got to order a port, I got to order a circuit, I'm paying data out charges. Well, there's a delta between data out over the internet from AWS and data out over Direct Connect. If you come with your own circuit to us, you're not using our internet connection, it's cheaper. So that delta, over terabytes of data per month, eventually there's a break-even point where you actually have paid for your circuit, your port, and you're actually saving money and getting better network performance with Direct Connect. So we have many Direct Connect POPs. We just launched Switch SuperNAP 8 in Las Vegas on Monday. And so there are 14 POPs worldwide. Different POPs take you to different primary regions, as you can see on the left, or on the right, excuse me. What that means is that's the region where this POP gives you private connectivity to your VPC with a VLAN, a private VLAN, that you can extend over that physical circuit to the particular VPC or VPCs in your region. You can always, in the US, hit other AWS regions publicly over our public transit backbone, but you cannot extend a VLAN privately. You could do a VPN connection across that AWS public transit backbone, but you can't do a private VLAN, as we're going to talk about in the coming slides. So, we also have many direct connect partners, and I wanted to dispose of a myth here as well. You don't have to use a partner to get to AWS. Any telecom provider that can provide the right requirements on your network circuit can get you to AWS. If they can get you from your direct connect or the direct connect POP to your data center, and they can build you a 1 gig or 10 gig circuit, you can order direct connect from them. The thing is, they might not understand the process, how LOA CFA works, how you extend the circuit to the AWS colo or cage, and so sometimes there can be a little bit more confusion. So that's why it's good to use a partner. But if you're trying to add AWS VPC to your MPLS IP VPN network, and it's not one of our partners, I mean, there's good reason to use somebody else. So, I wanted to talk about a couple different types of direct connect, hosted versus dedicated. So I've been talking to you about dedicated direct connect here, and there's also this other type of direct connect called hosted direct connect, and this is where like the dedicated is where you order the 1 gig or 10 gig port from us, and then you order a circuit that's extended to that port. With hosted, you've got telecom carriers or partners. There's a couple of partners out there that are doing this right now today that have already gone and built out networks to all the different AWS Direct Connect POPs, and they've bought big ports from us. And simply what you're doing is you're buying an Ethernet circuit from them, and you're having them extend that through one of their ports logically into the AWS cloud. That's essentially what hosted is. And what's nice about it is you can start at a 50 megabit per second circuit and scale that all the way up to 500 megabits per second. So you can increment that circuit and order it in 50 megabit per second increments, so you don't have to start at 1 gig. And it's hosted, it's all taken care of for you. There's also many different types of direct connect. There's point-to-point direct connect, things like wavelengths, private lines, Ethernet virtual private line. There's also things like full mesh, IPVPN, or VPLS over MPLS. These technologies also are available for direct connect termination. So here's some examples. Why would you want to use one over the other? Well, point-to-point, let's say you're moving massive amounts of data back and forth from your data center to Amazon Web Services VPC or something like that. Point-to-point circuit's going to be great. It's the best bang for your buck in terms of cost per bit. You're going to get the most data movement from it, and so on. MPLS or IPVPN costs quite a bit more per bit, but let's say you've got 100 sites on your network, and they all want to talk to private apps that are running in AWS. Do you want to backhaul them through your corporate data center, or do you want them all to talk over your QoS based IPVPN network out to AWS? Might be a better topology for you, or a better network architecture for you. And I can also see hybrid scenarios where you might have a point-to-point from your data center. You might have an IPVPN circuit, going out that all your private app connectivity goes over for all your LAN sites. And then lastly, one might use the other one for backup. All right, so there's also some simplification that can be achieved with using Direct Connect. So instead of running multiple VPN connections over the public internet to each VPC, Direct Connect can be used to consolidate connections. And like you can see over this physical connection here, we've got 5 private virtual interfaces and 1 public virtual interface going out to the AWS public endpoints. So I've consolidated what would have been 4 VPN connections down into 1 physical trunk, and VLANs running out to each one of my VPCs that have extended out to the VPN gateway. So there's some simplification can be done there as well. All right, so last point here. Use AWS Marketplace for networking and security software needs. So there are many software vendors and hardware vendors that have gone and created images with their best practices baked into that image out in our marketplace. Many networking vendors, I actually did a search here on firewall, and you can see you've got a variety of firewall vendors that are available with their software baked into an image that can run on EC2. And the marketplace gives you the ability to launch these 1 click and pay by the hour for that software. And there's many different types of software out there: web application firewalls, intrusion detection and prevention, cloud routers, and all sorts of other applications, BI, analytics, you name it, SAP HANA. So check out what's available out in the marketplace. I wanted to leave you with a couple other sessions to attend. So coming up in here is from one-to-many, evolving VPC design, and multi-VPC architectures, HA-NAT, scaling out your NAT, and many other advanced topics are going to be in that session. So this is kind of the warm-up for that session. Also, tomorrow, another counterpart of mine, Steve Morad, is going to be offering something called Black Belt Networking for the Cloud Ninja, which is going to talk about network automation and advanced tagging patterns, cross-region peering, manipulating IPs, multicast overlapping networks, network monitoring, and more. So that'd be another good session to talk, to attend tomorrow at 11 a.m. And thanks everyone for coming. I really appreciate your attendance. Don't forget to provide feedback. That's important to all of us. Thanks again. Thanks.